Hello everybody, welcome to another video lesson. Today we're going to be looking at hyperbolas. We've looked at parabolas, ellipses, and circles. Now we're going to look at hyperbolas. After today we're going to be able to analyze, graph, and identify equations of hyperbolas. But before we get started, I want to introduce you guys to somebody. Everybody meet Gilbert. This is little Gilbert, our little adoption, foster puppy. He's whining right now because he doesn't like this room. But, okay, get out. Oh, that was Gilbert. We have been fostering him for a month or so now. And I just wanted to show him off because he was super cute. And if you are interested in adopting or getting a dog, I would encourage you to adopt instead of buy, because there are plenty of dogs out there who need your help. And if your parents don't let you get a dog, maybe you could convince them to let you foster one, because eventually they will go away and get adopted, hopefully. All right? So with that, let's go ahead and get started with our concepts. All right, looking at hyperbolas. Okay, we've been talking about this term locus, okay, our locus of points that are fulfilling some geometric property, okay. For our hyperbolas, okay, we have this absolute value of differences, okay, between two distances from the foci, and that's going to stay constant. And I know that's a lot more wordy, but I'll go ahead and pull up our pictures here. Okay, when we had an ellipse or a circle, okay, what we had was our distances were being added together, and that sum was the same, right? Okay, so now anywhere on my hyperbola, okay, if I take these two distances for any point P, okay, so d1 minus d2, that absolute value is just going to be equal to the absolute value of any other distances. Okay, you can come way over here, take a look at point Q, and the distance from the foci to point Q, okay, the absolute value of the difference of those distances, very wordy, okay, but that is going to just be equal. All right, so that's kind of, hopefully that helps seeing the equations there. It's not as complicated as it sounds from the words. All right, okay, we have a bunch of components of our hyperbolas. Okay, we've got our center. Okay, our center now is going to be the center of these slant asymptotes, which we've seen slant asymptotes before, okay, but that's going to be the center now of our hyperbolas. We have our vertices here, okay, so if you were to kind of cut this in half at the center, you might see this as a parabola, right, with a vertex right here, okay, but now we just have these two curves, so we have two vertices now. Okay, we've got our foci, okay, we've got F1, F2, those are both our foci. And then we've got our curve, okay? We also have a couple of axes here, similar to how we had multiple axes with our ellipses, okay? Okay, we've got this axis, kind of this long axis that goes through our foci and goes through our vertices, okay? That is called our transverse axis, okay? So if you hear me saying transverse axis, that is what I'm referring to. And then perpendicular to that is going to be our conjugate axis. And notice I put in here, transverse axis has a length of 2a, and conjugate axis has a length of 2b. Okay, we're going to be using that to help us sketch these later. All right. Okay, so go ahead. This is the main slide to take down. Okay, we've got sideways parabolas, or hyperbolas, sorry, and we've got upright hyperbolas. Okay, the difference being is here, okay, notice I also, with my equations, I have this minus sign now, okay? It's been a plus sign up until now. Now I have this minus sign. Okay, so now I've got a squared minus b squared in my denominators, okay? A squared minus b squared in my denominators. Hey, Shaylin, is something smoking? Okay, so we have a squared minus b squared in our denominators now. So what determines, or how we can see if it is sideways or upright, is going to be if this first term is x, okay, has x in it, x minus h quantity squared, or if it is y minus k quantity squared, okay? So if I've got x over Okay. If I've got x over my a squared, then that's going to be sideways. And if I've got y over my a squared, that's going to be upright. Okay. And then I mentioned this, if you guys take all this down, okay, I mentioned this A, B, and C relationship. We've seen this before, okay, this relationship with A, B, and C. Let's take a look at how it kind of helps us graph these hyperbolas, okay, and what it looks like with our hyperbolas. Okay, so for these hyperbolas, A is going to be the distance between our center and our vertex, okay? Center to vertex, that's going to be A. Okay, so A is some distance. All right. Now, if I go up to my vertex and then I take a 90-degree turn, okay, so I'm going perpendicular, okay, to kind of this, my transverse axis, okay, going perpendicular to my transverse axis, and I go out, okay, I am going to go out until I hit my slant asymptote, all right, my slant asymptote. That length right there is B, okay? So the distance between the center and this line that intersects my slant asymptote is B, all right? And then if I have the distance from center to my foci, that is our C value, okay? So C is, again, going to be greater than our A value and our B values, okay? Okay, so we're going to look at discriminants now. So you guys have seen this equation, right? This looks like our quadratic formula. We've seen this before, and we referred to our discriminant as what's inside of the radical, right? This b squared minus 4ac. Okay, now we have this general form. We can find our discriminant for our conics with the general form for conics, okay? And the discriminant is the same thing, actually. It's still b squared minus 4ac. Okay, but now I can go ahead and I'm just taking my A, B, and C directly from the general form equation and plugging them in. And I can tell what type of conic I'm dealing with when I do that, depending on what the discriminant is. Okay, so if the discriminant is less than 0, then I know I'm either working with a circle or an ellipse. Okay, and then if B equals 0 and A equals C, then I have a circle. Okay. But if either of those are false, okay, so if either B is not equal to 0 or A is not equal to C, then I have an ellipse. Okay, so that's why we said circles are kind of these special forms of ellipse, or these special types of ellipse, all right? So if these conditions are not met, then it's going to be an ellipse. Okay, if my discriminant equals 0, then I know I have a parabola, and if it's greater than 0, then I know that I have a hyperbola on my hands. Right? So those are our concepts here. So let's go ahead and get into our examples. All right. First one, we're going to graph. Okay, graph our hyperbola given this equation. Okay, so taking a look at our orientation here, 5 is our greatest denominator, right? And that is under the y term, which tells me that I have this vertical orientation. Okay. My center is hk, which we're going to get from the top here. So I've got x minus h quantity squared and y minus k quantity squared, and I don't have anything actually in my equation, so I know that h and k are both 0. Okay, so we need to know our a and our b. That's just going to be the square root of our denominators of our fractions, and I'll go ahead and put the decimal approximation for a square root of 5 and square root of 3 up here. Okay, and then our c value we can find by this relationship that we've seen before. Okay, it's going to be the square root of 8. Again, I'll put the decimal approximation up there. Our vertices, we have h and then k plus a, all right, which we know from the center. Okay, if I add a, that's how I get to my vertex. Okay, if I add a, and because it is vertical, I'm adding it to the y coordinate for my vertex, okay, for my vertices. So if this was a horizontal hyperbola, then I would be adding a to h, right? Because I'm going this way. I'm adding a this way, or I'm subtracting a going to the left, okay? So I get 0, negative root 5, and 0, positive root 5. Okay, and then my foci, we have h and then k plus or minus c. Okay, and we found c earlier, so I've got 0, and then negative root 8, and 0 positive root 8. Then we can go ahead, and I already have them here for us, but we can find the equations of our asymptotes, okay, which are given by this equation here. So we know a and b and k and h are both 0. So that's going to simplify, and the decimal approximation is going to be plus or minus 1.29x. Okay. All right, and then we can go ahead and start plotting our points. So I've got our center here at 0, 0. We've got our vertices here. Okay, we're going up from the center 2.24 and down from the center 2.24. And then we're going up from the center 2.83 and down from the center 2.83. That's how we find our foci. Okay, and then we can go ahead and plot a couple more points here. If I just solve this equation here for y, that's what I have here. And then I'm just picking a couple points. So if I pick 2, then I get plus or minus, don't forget I have plus or minus here, 3.42. Okay, so I'll go over 2, and then I can go up 3.42 or down 3.42. And I know that I'm actually going to be symmetrical about my transverse axis, okay? So if I chose 2, and my center is about the origin, then I should also choose negative 2, right? Because that's going to yield the same y values, okay? Because, again, we are symmetric about this transverse axis, okay? So that's enough information there. We can go ahead and fill in our curve, and that is what our graph will look like. All right, and again, these orange dotted lines are our asymptotes, okay? So this is roughly y equals plus 1.3x and minus 1.3x, okay? That's what those dotted lines are. All right, let's take a look at another graphing example. First, we are given this in general form. So the first thing we need to do is rewrite our equation in standard form, okay? And we know it's a hyperbola, so that kind of helps us out. But first thing we need to do is sort of rearrange this. Okay, so we have our 2x squared minus 12x minus 3y squared equals 36. And then we can go ahead and factor out a 2 here from our x's. And then I'm going to factor out this 3 from our y, okay, from our y squared. And now you'll notice I left some room here, which usually means we are completing the square, which is what we're going to have to do here. Okay, so I'm taking this coefficient, I'm halving it, and then I'm squaring it. Okay, so that's going to give me plus 9. Now, notice that I added 2 times 9 on the right-hand side. That's because I have this 2 here. So really, if I redistribute this 2, what I actually added here in red would be 2 times 9, or 18. So that's why when I add this onto the right-hand side of my equation, I have to have that 2 times 9 and not just 9. Okay, so let's go ahead and rewrite this with the completed square. But now what we need to have on the right-hand side is a 1, right? So I need to divide everything by this 54. And our simplified equation comes out to x minus 3 quantity squared over 27 minus y squared over 18 equals 1. All right, and then from here, we can find our a, b, and c values. We can determine our orientation. We can find our center. We can find our vertices. Again, this is just using A, B, C, H, and K. We can find our foci, and we can find our asymptotes, okay? And these are all just coming from that like second or third slide that I showed you guys. We've got all these formulas here. However, if you kind of recognize that this is a horizontal orientation and I have my center at a certain point, I can easily find my vertices by going over A in both directions. I can easily find my foci by going over C in both directions, right? And then I'll show you in a bit how we can help with these asymptotes here also. Okay, but using this formula for our asymptotes, we get y equals plus or minus 0.82 parentheses y, or x minus 3, okay? So all the useful information here we'll put on top, and we'll go ahead and start graphing what we have here. Okay, so again, what we have in green are our slant asymptotes here. We got our center at 3, 0. We've got our vertices here, and then just beyond those, we have our foci. Again, I'm just using our decimal approximations here. Okay, now what we could do here, we can make our table, right? we can plug in some x values, get some y values. But what I do want to show you with this graph here is I'm going to use my a and b values in a way that could help, especially with our asymptotes, okay? Especially with these asymptotes. So I mentioned if I go over a, right, my a is 5.2. So I start at the center, I go over 1, 2, 3, 4, 5, and then roughly 0.2. Okay, you'll notice this is my a length, right? And then from my vertex, okay, if I go up, directly up, okay, so I'm perpendicular to this transverse axis, I'm going straight up. And if I go up by a length of b, okay, so 1, 2, 3, 4.24, okay, then I should hit my slant asymptote, okay? Should hit my slant asymptote. This distance right here is our 4.24, okay? And the same thing on this side. Okay, I go over A, hit my vertex, or if I just have my vertex plotted, I go up by 4.24 or down by 4.24, which is my B value, actually. Okay, that's my B value. So now from here, if I just connect these, I have these two parallel lines here. If I connect these, I create this square that we kind of saw earlier. Okay. Now this square, this length here, I said that this is A and this is A. So this length total along the bottom is just 2A. So that's going to be 10.4. Okay, the corners of this rectangle are going to be where my asymptote lies. Okay, my slant asymptotes are going to go right through the corners of this rectangle every single time. Okay, so that's a good, easy way for us to write our, or to graph our slant asymptotes, okay, especially when I have a slope, right, of 0.82. That's kind of hard to graph, okay? So this little trick helps us to accurately graph that slant asymptote using this little rectangle, okay? All right, let's get through a few more examples here, okay? We're going to write the equation with given some characteristics, okay? So I'm given our vertices and our conjugate axis length, okay? So I notice that I have the same x value in my vertices, which tells me I have a vertical orientation. The center is just going to be the midpoint of our vertices, okay? So I know I have the same x value, but it's going to be the midpoint of the y values of the vertices. Okay, so take the midpoint of 6 and 2, I get 4. Okay, that automatically gives me h and k, right? And I know A is equal to 2 because if I start at 4 and I go up 2, I hit one vertex, okay, because I hit 6. And if I go down 2, I hit my other vertex, which is 2, right? So my A value is the distance from center to vertex, and that's going to be 2, okay? Our conjugate axis length has a length of 2b, okay, and we're told that that length is 10 units. So I can solve this little equation for b and find out that b is equal to 5, which gives me a squared equals 4 and b squared equals 25. So I have h, k, a squared, and b squared. That's all I need to write my equation, which is going to look something like this. Oh, and I need orientation, okay? So using that same thought process, go ahead and see if you can find the equation of this example here on the right. Okay, given the foci, all right, hopefully you pause the video, given the foci and the equations for the asymptotes, this is the equation that I got, and this is the process, so go ahead and check your work, and we'll move on. Okay, second to last example, we have eccentricity of our hyperbolas. All right, so we know that our first denominator is a squared, and our second is b squared. Okay, so our E does not change, okay? This formula for eccentricity does not change. Okay, so all we need to do is find C, and we have this relationship here for C, which we can use to easily find C, because we already have A squared and B squared. So C is going to be the square root of 90. All right, so I've got A squared equals 15, so A equals square root of 15. So E is going to be root 90 over root 15, and if I plug that into my calculator, I get 2.45. Alrighty, so let's take a look at Identifying conics, okay? So we're going to use the discriminant to identify each conic section given the conic in general form, okay? So here I'm just going to rearrange so it's in true general form. So I've got x squared, then xy, then y squared, then x, then y, then our constant, okay? So from here, my a, okay, I just get a from right here, so that's -2. B is going to be this coefficient of 4. C is going to be this coefficient of -8. And then D, E, and F I can also list out, but I don't really need for my discriminant, okay? Okay, so our discriminant formula is the same as we've seen before, b squared minus 4ac. I just plug in my a, b, and c from what I listed out over here, and I get a negative value, which tells me I either have a circle or an ellipse. Not an eclipse, an ellipse. Circle or an ellipse. Okay, so how do I know which one is which? Is it a circle or an ellipse? Well, if b is not equal to 0, which in this case it is not, or a is not equal to c, which again it is not, then we have an ellipse, okay? So go ahead, use that exact same process and see if you can't find and identify the conic here on the right. Go ahead and pause the video and give that a shot. Okay, this is the process that I used and found that I have a positive discriminant, which means we're dealing with a hyperbola, all right? So that is all that I have for you guys today. Good luck with your practice.